This video is a brief overview of motion on an inclined plane. Motion on an inclined plane is when an object is moving on a surface that has an angle. For example, a ball rolling down a hill, or a skier gliding up a jump. When the only force acting on the object is gravity, for example, the ball speeds up as it rolls down the hill because gravity pushes it down, and the skier slows down as they glide up the jump because gravity is pushing against them. In both of those examples, gravity is what's causing those objects to speed up or slow down. And this acceleration due to gravity on an inclined plane will be equal to A is equal to plus or minus g sine theta. G is the acceleration due to gravity, so it's equal to 9.8 meters per second squared. Theta is the angle of the incline. So when you're using your kinematic equations to solve motion on an inclined plane questions, the acceleration value you will use is A is equal to plus or minus g sine theta. Now it's important to recognize that these inclined planes form right-angled triangles, which have a hypotenuse, an opposite side, and an adjacent side. And that means you can use trigonometry to solve for the angle or to solve for the object's displacement, delta x. Let's practice by jumping into a problem. So in this question, we have a ramp that is 20 meters long and 10 meters tall. And we know this is an inclined plane, so it'll also have some angle. And what happens is a ball is released from the top, and we want to know what is its final velocity at the bottom of the ramp. Now we know the initial velocity is 0 meters per second because the ball is just released from the top. We also know, because this is motion on an inclined plane, the acceleration is plus or minus g sine theta. Now in order to solve for the acceleration, we need to find the angle. To find the angle, we need to use some trigonometry. So what we have here is a right-angled triangle, and we know it's 10 meters tall and 20 meters long. And that means our opposite side is 10 meters and our hypotenuse is 20 meters. We need to use sine theta is equal to opposite over hypotenuse to solve for the angle. All we need to do is rearrange and isolate for theta, then plug in our opposite and hypotenuse sides, and we find that the angle of the incline is 30 degrees. Now we can solve for our acceleration, and we find that the acceleration would be plus 4.9 meters per second squared. Now, how did I know the acceleration would be positive? Well, the velocity vector is pointed to the right, and the ball will be speeding up as it goes down the ramp. That means the acceleration vector has to be in the same direction as the velocity vector, so it will also be to the right, and it will be positive. Now, the last thing we know is that the ball's displacement, delta x, is equal to 20 meters, the length of the ramp. And with that, we have enough information to solve for the final velocity. We will just need to use the Vf squared is equal to Vi squared plus 2a delta x kinematic equation in order to solve. And so let's do it. All we have to do is plug in our values and solve for Vf. And what we find is that the ball's velocity at the bottom of the ramp would be about 14 meters per second. And that's the end of our brief introduction to motion on an inclined plane. I hope this helped you understand how to use your kinematic equations to answer motion on an inclined plane questions.